Let's look at integration by parts. So the key notes include the integration by parts formula, which is the integral of uv dash, which equals to uv minus the integral of vu dash, and we choose u in the order of I late, which is inverse trig, then logarithms, then algebra, then trig, and then exponentials. The first example says integrate x sine x with respect to x. Now since we have a product with algebra and trig involved, we can use integration by parts to integrate this. So we choose u in the order of I late. In this case we have algebra and trig involved, and so using I late we label u as the algebra, which is x. So we have let u equal to x, then u dash equals to x differentiated, which is 1. And so therefore v dash must now equal to sine x, and now if we integrate sine x we get minus cos x. So therefore v equals to minus cos x. Now using the integration by parts formula, we have that the integral of x sine x is equal to uv, which in this case is x times minus cos x, which becomes minus x cos x, minus the integral of vu dash, which in this case is minus cos x times 1, which gives us minus cos x. And we're integrating this with respect to x. And so now if we work this out, we get minus x cos x minus, and now the integral of minus cos x is equal to minus sine x. So we have minus sine x and then plus c since we don't have any limits. And so if we simplify this, we end up with minus x cos x. Now minus sine x becomes plus sine x, and then we have plus c. And this is the integral of x sine x. Now the second example says integrate x squared ln 2x with respect to x. Again, we have a product, and so we can use integration by parts, and so choosing u in the order of I late, we have algebra and logarithms involved, therefore u must be the logarithm, which is ln 2x. So we'll let u equal to ln 2x, then u dash is going to be the derivative of ln 2x, which is equal to 2 over 2x, and this simplifies to 1 over x. Then v dash is equal to x squared, and now we're going to integrate to work out what v is. So integrating x squared, we add 1 to the power, which gives us x cubed, and then we divide by the new power, which is the same as timesing by a third. Now using the integration by parts formula, we have that uv, which in this case is ln 2x times a third x cubed, gives us a third x cubed ln 2x minus the integral of vu dash, which in this case is a third x cubed times 1 over x, which simplifies to a third x squared, and we're integrating this with respect to x. Now if we work this out, we get a third x cubed ln 2x minus, and now integrating a third x squared, we add 1 to the power, which gives us x cubed. We then divide by this new power, which is the same as timesing by a third, so a third times a third gives us a ninth. And since we don't have any limits, we add plus c. And this is the integral of x squared ln 2x. Now the final example is to integrate e to the x sine x with respect to x. And since we have a product, we can use integration by parts here. So we're going to choose u in the order of I late, and since we have an exponential and a trig function, we're going to let u equal to the trig function. So we let u equal to sine x. If we now differentiate this, we get u dash, which equals to cos x, and now v dash must be equal to e to the x, and v equals to e to the x. Now using the integration by parts formula and also writing this out, we have the integral of e to the x sine x with respect to x equals to uv, which is sine x times e to the x, and that gives us e to the x sine x, minus the integral of vu dash, which in this case is e to the x times cos x, and we're integrating with respect to x. Now we need to use integration by parts again to integrate e to the x cos x. And since we have an exponential and a trig function, we're going to choose u in the order of I late, which in this case is going to be cos x. So let u equal to cos x, then u dash equals to minus sine x, and v dash equals to e to the x, and v equals to e to the x. So we're now going to end up with the integral of e to the x sine x with respect to x equals to e to the x sine x minus, and now remember the integral of e to the x cos x, we're going to use integration by parts on this. And so we have uv, which is e to the x times cos x, minus the integral of vu dash, which is going to be minus e to the x sine x. And then we're going to integrate this with respect to x, and we're going to close the bracket. Now this becomes the integral of e to the x sine x with respect to x equals to e to the x sine x. And now if we expand the bracket here, we get minus e to the x cos x. And now the minus inside the bracket, the minus here is going to become plus, and then expanding this out with the negative gives us minus the integral of e to the x sine x with respect to x. And now we can add the integral of e to the x sine x to both sides. If we do that on the left hand side, we're now going to get 2 lots of the integral of e to the x sine x with respect to x equals to, so we get e to the x sine x minus e to the x cos x. And when we add the integral of e to the x sine x with respect to x on the right hand side, it will cancel with this negative term. And so finally we divide both sides by 2 to get the integral of e to the x sine x with respect to x equals to a half e to the x sine x minus a half e to the x cos x. And since we're integrating without limits, we add on plus c. And this is the integral of e to the x sine x with respect to x.